So we're going to solve problems where quantities change over time. Sometimes it helps to make more than one drawing to show how the quantity changes. Let's begin with a box of chocolates. When a box of chocolates was full, it weighed 1.1 kilograms. After half of the chocolates were eaten, the box with the remaining chocolates weighed 0.7 kilograms. How much did the box weigh without the chocolates? Let's think carefully. The full box includes the weight of the empty box plus the weight of all of the chocolates. Together, that is 1.1 kilograms. After half the chocolates were eaten, the box still includes the weight of the empty box plus half the chocolates. Together, that is 0.7 kilograms. The difference between 1.1 kilograms and 0.7 kilograms is 1.1 minus 0.7, or 0.4. That 0.4 kilograms represents the half of the chocolates that were eaten. So, half the chocolates weigh 0.4 kilograms. All of the chocolates together would weigh 0.4 times 2, or 0.8 kilograms. So this is all of the chocolates. The full box weighs 1.1 kilograms. So the empty box will weigh 1.1 minus the weight of the chocolates, 0.3 kilograms. So the box without the chocolates weighed 0.3 kilograms. This time we didn't use a pitcher, but we did do it in multiple steps, slowly, without any algebra. So now, let's look at solving this problem using algebra. For algebra, we're going to let B be the weight of our empty box in kilograms. And C is going to be the weight of our chocolate. Once again, given in kilograms, since that is the unit our problem is using. Then what we know is that the box plus the chocolates weighs 1.1 kilograms. We also know the box plus half the chocolates is equal to 0.7 kilograms. And we can actually subtract these two equations. When we subtract, we need to change the sign of all of the terms. So I'm going to go ahead and distribute a negative sign there. B minus B will be 0. C minus 1/2 C is 1/2 C. And 1.1 minus 0.7 is 0.4. I can then multiply both sides by 2 to get that C is 0.8. I can then use that first equation, B plus C, which we just said was 0.8, needs to be equal to 1.1. Subtracting the 0.8 from both sides gives us that B is equal to 0.3. So we got the same answer both ways, although the algebra did require solving two equations with two variables, whereas before we didn't have to think about that. Now let's solve the muffin problem. A bakery sold 3/5 of its muffins. The remaining muffins were divided evenly among 3 employees. Each employee got 16 muffins. How many muffins did the bakery have at first? First, let's find out how many muffins were left. There were 3 employees and each employee got 16 muffins. So 3 times 16 is 48. 48 muffins remained. The bakery sold 3/5 of the muffins. So the remaining muffins were 2/5. If I had a strip diagram, we could break this up into 5 parts. And we'll just say that those are equal. 2 of those parts represents the 48 that we just found. So 48 divided by 2 gives us 24. Each of these rectangles, the smaller ones, are worth a total of 24. The whole amount is 5. 5 times 24 is 120. So there were 120 muffins at first. But let's do this with algebra as well. We'll let m be the number of muffins that we started with. And then what we know is that the remaining amount was 2/5. We sold 3/5, which means we have 2/5 of the total amount left. And that should be equal to our 48. 3 times 16. How many muffins were given to employees? We can divide both sides by 2. When we do, we get 1/5 m is equal to 24. Then we multiply both sides by 5. When we do that, we get m is equal to 120 muffins. These problems are a little complex, but they are very manageable when we slow down and track what each quantity represents. When quantities change, make sure you know what each number represents at each stage of the problem. A strip diagram or an equation can help organize that thinking.